evaluate if possible. So in A, we have the limit as x tends to 9 from the right-hand side, from above, of square root of 9 minus x. So the first thing we want to do here is we want to determine the domain of this function. So in this function, the radicand 9 minus x has to be greater or equal to 0, which will happen. So we want to rearrange this isolate x. So we subtract 9 from both sides, multiply both sides by -1, and reverse the inequality. So that's our domain. So x has to be less than or equal to 9. Now here in the limit, they're asking us to approach 9 from the right, which means that we will be approaching it by setting x slightly larger than 9, and we move closer to 9. Now we cannot pick x larger than 9 because x has to be less than or equal to 9. So in this case here, we would say that the limit as x tends to 9 from above of square root of 9 minus x, that limit does not exist. It's an empty set. In B, we have the same scenario, but this time we're approaching 9 from below, from the left. Okay, so that is possible. So x will be less than 9, which is within the domain. So here what we can do is we can just substitute in the 9. So we're going to get square root of 9 minus 9, which equals to 0. In C, we have the limit as x tends to -5 from below of x plus 5 over the absolute value of x plus 5. Now, in the denominator here, we have two possibilities. So the absolute value of x plus 5, can either be the argument to the absolute value can either be greater or equal to 0, which will happen when x is greater or equal to -5, or the x plus 5 can be negative, so less than 0, which will happen when x is less than -5. Now, in this question, it says that the limit as x tends to -5 from below. Okay, and that scenario means that x is going to be less than -5. So this is the scenario. So that means we can rewrite this expression here as the limit as x tends to -5 from below of x plus 5. And now x plus 5 in the argument of the absolute value will be negative. So we're going to go negative x plus 5. And now we can see that this x plus 5 and this x plus 5 just cancels. So that means we're left with the limit as x tends to -5 from below is going to be -1, which equals to -1. It's this is a constant, and whenever we have a limit of a constant, the limit is the constant.